Hello, welcome back to Sushi Live Noodling. In this episode, I want to share with you how I created this the design of this sushi bar. So it's basically it's really simple. It was originally just this logo, the Yin Yang logo. Oh, I didn't color it like black and white and black, but yeah, that's basically the idea. You start with the logo and you make a cutout, and then you animate it with noise. So it doesn't come with this particular logo. So let's save it. Okay. Oh, for the signage thing, you just use text and just write it down. Okay, so this is the logo. So I started this one, I believe, so with any kind of logo, whether it's like this Yin Yang or the Batman logo, whatever, you basically try to create the shapes. So like in this case, you have circle, obviously, and then you have this half circle and another half circle, and you have another two circle. So that's basically it. And so I started with the circle, and that's the same exact circle, and this is like half degree, so it's a half circle. This one is mirror, and I move it down. So if I make any changes, I think it's gonna change everything. So I just probably use the control click so I can show you what's going on. Let me hide everything. So you can see at the bottom there, that's the visualizations of that part. So obviously it's half circle and one of them is moved and the other way is moved negatively, and then I use list join. So it's joining those two, and I use UV connections, and I merge it by distance. I merge it in the center. Then I have the bigger circle with a more resolutions, double the resolutions. I join the mesh, intersect the edges, and use this Planar Edgenet. So Planar Edgenet is super useful in that case. It basically fill any kind of hole. So if you actually design this using a grease pencil, so if I just make like this really badly drawn grease pencil like that, you can use the GP macro, grab the annotation grease pencil, so this, if you use it with Planar Edgenet and Intersect, this will basically do the same. Probably need to mesh join. So 1, 2, 3, 4, connect all of them. It's 2D. It should recreate this into, oh, okay, I connected it. So you have connection, polygon edges. Okay, yep, it works. So I can actually bake this, and I should get a cutout as well. So I can separate it if I use the polygon boom. So this will separate it, right? There you go, bake. Now, so yeah, that's basically it in a nutshell. So I don't need to explain it. I can delete it. Okay, continue on. We are up to here. The rest of them, yeah, another like we have two little circle. I moved it to the position. I use merge mesh. It seems merge mesh things, I use this a lot, and this causes a lot of lines, but yeah, that's for now we have to deal with it because it's separating the vertices and faces, and often it's separating the vertices and edges. Here I'm using polygon boom and then extrude region, solid split, and then etc. Let me bring back our hidden objects. Show and hidden objects. Okay. Yeah, the rest of them. So after polygon boom, each of the shape is being separated, right? So that we have this part. Obviously, it needs to cut it like that. Just I think the Planar Edgenet actually does that. It's separating each part. I quite like it. It's like a jigsaw puzzle. So once you have that, what happens next is extrude region. I use extrude region to randomly extrude it based on the noise. So if you look at these nodes, it looks like a lot of nodes, but actually it's only doing small little operators, and it's quite simple one. So this is time multiply by this value goes into the vector. This vector is to move the random vector. Here I have count of 8 because we have 8 shapes. I can randomize this. Okay, so that's a starting value, single random number, and I move that value, and the output goes into vector noise, and this vector noise, of course, this generate noise, but the output can be scalar, and I use map range with the list limits turned on, so I can set up the minimum, the new minimum, and the new maximum value, and then I split the value so it fits this extrude region. So in the end, so we have this result, and push it along the normal, and the output is this 8 different 3D shapes. For each one of them, I give a different material, just so that we can look at it like this. And if you ever want to export this as a USDZ or as AR, that's easy. Just simply export it out, selection only, and the USD can be converted into USDZ, or this can also be just like a normal GLB AR. All right, so this is the Yin Yang project that I worked on yesterday, just for fun. You can make yourself, like, see, like the grease pencil here. I mean, you can be more precise if you properly want to do this. So you create grease pencil objects, you draw, and of course you can create a circle. Here's a quickie one. Middle click. There's another method. There are a lot of methods to create this kind of logo. And middle mouse click, and of course this smaller circle while holding options and shift on the Mac. Okay, middle mouse button to complete it. Yeah. And with this guy, let's see, you often get a lot of sampling there. It's really, this pencil is really high details, vertices wise, and so I deleted the one I had before, right? But the GP macro from this pencil. So I'm showing you this 3 times. mesh join. Intersect Planar Edgenet. So it's a mouthful node's name. 1, 2, 3, 4. Tap V. So this result is dependent on this. I wonder if they are connected properly. Yeah, I think so. They're about right. Something funky going on there, but oh yeah, edges, faces, polygon, boom. So we have 3 shapes. One of them didn't seem to make it. Wonder why. But they need to be like enclosed shape anyway. So yeah, you got the idea. So it's a quite easy exercise, quite fun to make. But you can make your own. You can draw it using grease pencil precisely, or just like a doodle like this, and you can cut the shapes. It's so much easier. You can do it in like a few seconds. But there you go. Hopefully you find this interesting and useful. Let me know what you think, and I'll see you next time. Thank you. Bye.